Hello there, this is Dr. Witten, and we are going to do a t-test today, specifically an independent samples t-test. So this is a t-test where you have completely different people in each of the groups. So we've got the placebo group versus people who got 1 milligram of something or another, who knows. So let's say it's an antidepressant, and these scores represent scores on some depression scale. Then these people in this placebo group that I'm highlighting now got the placebo and only the placebo. So there's 6 people here, and they all got the placebo. And then a different group of people, another 6 people, got 1 milligram of an antidepressant. And these are different people. So there's a total of 12 people in the whole sample. And in each group, there's a total of 6. Right? So let's look at this. So some things that you're going to need to plug into this scary-looking formula that's actually not so scary-looking once you break it down. I mean, look at all of the N's in there. Everybody knows what N means, so we're good. Right? So we're going to need the means, and we're going to need the variance. And I'm serious when I say we need the variance. Right? So a lot of people we'll want to put the standard deviation in here, but actually the whole thing is under this big square root, right? So like that's why I've already have this highlighted. It's so important. See this big square root? So what you've got to put here in this part of the formula is the variance. So I know in the formula it is s squared, right? So hold on, let me go to the writing tool here. So in the formula, this is s squared 1, right? And so some people confuse that with the standard deviation, but it's not. It's the variance. So we're just going to do this. You don't need to plug in the standard deviation here. Okay, so let's do it. So we're just going to start plugging in the means right away. So the sub numbers here, like here, means the mean for group 1 versus the mean for group 2. So the first thing we plug into our formula, I'm going to write down here, is the mean for group 1 is 50. And just to keep the decimals consistent, I'm doing that. Minus the mean for group 2 is 24.5. Okay. And all of that is over the square root, which we're not going to forget, okay, of n for the first group, which is 6 minus 1, don't forget that either, times the variance, again, don't forget that either, of the first group, which is 38, plus, and for the second group, which again is 6 minus 1 times the variance, not the what? Not the standard deviation, but the variance of the second group. And all of this is going to be over 6 plus 6 minus 2. So in group 1, and for group 2, minus 2. Right? So all of that goes in brackets. And then there's this next part, which is just a bunch of n's, really. Super easy. So n for group 1 plus the n for group 2, which is 6 plus 6. And then n for group 1 times the n for group 2, which is 6 times 6. So we're going to actually, let's see. I kind of want you to see some of this. So there we go. That's better. Okay, so 50 minus 24.5 can easily be found to be 25.5. So yay, the numerator's done. Not too bad there. All right, remember our big fat square root. And 6 minus 1 is 5. right? And that's going to be times 38 plus 6 minus 1, again, is 5. And that's going to be times 34.7, right, over 10. Right? 6 plus 6 minus 12 is 10. So far, all we did was do the 6 plus 6 is 12 minus 2 is 10. And that's here. And then the 6 minus 1s, which are 5. And then 6 plus 6 is 12 over 6 times 6, which is 36. Okay. Then we just keep solving for this. So again, we've got the numerator, which is 25.5 over here. I'm going to move a second. I'm just going to take that away. Try to give you guys some room to see that. Well, yeah. Well, we'll just kind of start on solving this on the next sheet. You know what? Sheet of paper. Here we go. All right. So we've got our 25.5 as our numerator. Then we can work this out to remember the big square root, and then the 38 times 5 would be 190. And then the 34.7 times 5 would be the 173.5. And all of that, as you remember, is over 10. And then 12 divided by 36 is 0.33. So we continue to solve this. 25.5 over 363.5 over 10 times 0.33. So it's very good to see me doing this because I know my writing is atrocious. Like it is anyway. On these things, it's even worse. 25, oh man, see? 25.5 over, of course, this works out to be 36.35 times 0.33. And what did I forget over here? The big fat square root, big fat square root. So we've got 25.5 over, square root of 12.11, and I used 0.33, pardon me, I used 0.3333 to get that. So 36.35 times 0.3333. So continuing on, we get the square root of 12.11, and that should be 3.481. And we're going to divide that into 25.5 for our t value of 7.325. Now, if you look that up in the book to get the critical value with the degrees of freedom of 10, then it should show that it's statistically significant. But what I kind of want to talk to you about now is, it's something a little bit different. So some of you have asked about your SPSS, and I think part of the problem is that you're not understanding that like how to set it up in SPSS. So you would have here like we've got the, sorry, your independent variable and your dependent variable. I forget which is which, but this is like drug or something like that. And then the dependent variable was depression, probably. Right. And so here, for your independent variable, right, the first 6 are all going to be 1s, right? So the idea is that in an independent samples design, yeah, this looks terrible, I know. I'll show you a picture of it in SPSS, but I just kind of wanted to go over it quickly here as well. So remember that there are 12 people in the database, right? 6 in each condition. So in a database, we are going to first have, because they go down, this column is always the participant. It goes down like that. And so we stack them on top of each other. Right? So here, participant 1 scored a 55. The next one, 54, 43, 56, 42, and 50. And then in a completely different group, it's still part of that sample. Subject 7 really is the first one to get a milligram, and that person scored 23, then 28, 27, 24, 14, and 31. Right? And so the way that we distinguish, because we know that this is one group, oh wow, that's some highlighting, and this is a different group. Then here in the independent variable column, all of these get a 1, and all of the people who got the drug get a 2. And so when you get to the grouping variable, in SPSS, this is what they're talking about. It's just your independent variable, and in that little box that you have to fill out, you're just telling it that you need to divide it up into 1s and 2s instead of, say, like 0s and 1s or whatever. So I hope that helps. I'll try to put in this video like a little picture of it in actual SPSS as well. But until then, happy studying, and good luck on your test and your homework and all that stuff. Bye.